Like my close-up.
Put that in.
Please don't. Alright, good afternoon everyone. Today we're going to be working with electrochemistry. What we're doing right now is we're going to set up a galvanic cell. I hope I pronounced that correctly. What it is, if you look in your précis, it is a cell composed of solid copper anode, copper solution, which will go into the left side of our battery, also known as our half cell. It'll be connected via a salt bridge, which is made of agar and 1 molar potassium nitrate. That will connect us to the right side of our galvanic cell, which will be composed of silver nitrate solution and solid silver cathode.
Yeah.
So, let's get working on that. You guys want to apply the chemicals and I'll grab the metals?
I mean, I think it's just to fill the bottom. So.
Yeah, but no, you tell me this though.
All right.
That's what's into one of the small beakers.
Yeah, this is small beaker. Do you need one of those like little funnels?
Yeah. Do we need a funnel?
What are you adding right now?
No.
Silver nitrate.
To what?
To the right side of the.
You can just pour it in.
I'll go find us a funnel. Never mind.
Are you adding a specific amount or
10
just?
milliliters.
Okay, you are.
You need to have
Okay.
fresh copper atoms.
Or do you want us to just like all like put it in?
Yes.
Because Ingrid said just to put like a little bit.
Yeah, I was gonna say, just
Okay.
put a little bit in the bottom.
Okay.
Probably,
Ingrid said we can eyeball it into the beaker.
yeah.
Okay.
So what we're doing right now is just filling it to the top or to the very bottom of the salt bridge so that I can connect both solutions with each other. This way, the salt bridge will be able to balance out the negative and the positive side.
Is that enough?
Good color. No.
Maybe just a tad bit more.
That was a little much.
That's good. Okay. You just rub it.
Oh, okay, cool.
So what are you sanding?
So right now, we're sanding both of our electrodes. Right now, we're sanding the copper strip and the silver strip. The reason we're doing this is because naturally over time, metals will react to become metal oxides. So we're getting rid of all the copper oxides so we can have just copper in our solution. And that way we can obtain the most accurate results. Sure. If you don't want it.
Well, I know you were doing the first one. You have to keep consistent.
Alright, so under the assumption that that was positive or that was negative, we'll switch. So then, you want to put that one on the left side? Put this one on the right side. Wait, does it matter?
It's negative. Should we switch them if they're negative?
Well, it just says E-20. Hold up.
Put it in and see what you get. Oh my god.
Oh, perfect. Positive number.
If you
So
can
now
get
that
it
we have a
to
positive
stay.
number, we know that the reaction written out in the précis will work as stated.
Okay, it stayed.
So now what are you doing?
Alright, so we are well, we're done part B. So what we just did was we connected them to the pH meter, which reads the voltage in millivolts, and we have discovered that through the transfer of electrons between these metals in our galvanic cell, we have created 301 point uncertainty millivolts. So now what we have here is our galvanic cell, but instead of what we did in part B, it is now with a different concentration of copper sulfate on the right side. So here we have our copper strip connected to 1 molar copper sulfate, connected via salt bridge to our copper strip in 2 molar copper sulfate solution. As we can see on this pH meter, we are getting 19.6 millivolts in this reaction. So what we have here is the same setup for part A of part C. The only difference is now we're using 0.01 molar solution of copper sulfate for our galvanic cell. As you can see on the meter, it's reading negative 41.2.1 millivolts. The reason why it's negative as compared with part A is because the concentration for the right side of our galvanic cell is a smaller concentration. So what we have here now for part D, we've constructed a copper half cell using the copper strip and the copper sulfate solution. This time it's of 0.001 molar concentration. And the other half of our galvanic cell is composed of zinc chloride. So we have a zinc metal strip right here with a solution of 1.0 molar zinc chloride. And now we wait for our results to come in on this multimeter. I think that's what it's called. As you can see right now, it's fluctuating around the number of 1001 millivolts.
Cool.